Hello everyone, welcome to the 19th video on Snowpro core certification series. In this video, we are going to discuss about data loading and copy into commands in Snowflake. Data loading is all about how we can load the data into the Snowflake. So we are having lots and lots of options which are available to load the data into Snowflake, and copy into is one of the options which will be very helpful to load the bulk data into Snowflake. First, let us see what are all the data loading types which are currently available. This is a common thing which is across the industry. So, what are all the ways by which we can load the data is predominantly done by three different ways. One is the batch processing, where we will be processing the data or loading the data in the batches. As it is a batch processing, we will be aggregating the data over the period of time. Say for example, we will be doing the batch processing once a day or twice a day. So we will be aggregating that specific data over that one day. That will lead to bulk amount of data. So ideally, if you are doing the batch processing, the amount of data will be very high. Moving on to the second type, which we call it as a micro batch processing. It is not like the bulk processing. It can be done in a very smaller fraction of time, ideally for 1 minute or 2 minute interval. We call this micro batch processing as near real-time data loading, where we will accumulate small amounts of data and load it in 60 seconds interval. The time between loading each micro batch could be greater than 60 seconds, but usually no more than few minutes between loads. Moving on to the third type, which is the real-time processing. We can call it in different names like stream processing or continuous processing. It processes the data in real time, meaning loading the data as it is within millisecond or microsecond latency. Streaming tools such as Kafka are very best example for stream processing. Now we are just trying to understand the data loading tools. First thing is we can load the data directly using insert into commands. If you are from the data warehousing background, you might be aware of what insert into is all about. You can see an example here, insert into table 1 values. So we are manually inserting the data into the table. This can be used for development purpose or for testing purpose, but in the production case scenarios, these sorts of commands are not that much useful. Moving on, we can insert the data into one table from the other table as well. Here is the example. We are inserting the data into table 4 from table 3, which is similar in the schema type, meaning the same ID, F name, L name and city is there in table 3 as well. And we are just loading the Atlanta related values into the table 4. These type of things are very evident and widely used across the industry. Even in the production as well, you can see lot of commands like this. And there are some other ways by which you can load the semi-structured data into the tables. One example is the array insert, where we are constructing the array using array construct and we are loading it. And another example is the object construct, where we are trying to construct the object and we are inserting it into the table. So there are lot many ways by which we can insert the data using insert into commands. The other option is via the Snowflake's web UI. So Snowflake provides the option to directly upload the file from the Snowflake's user interface, but there is a caveat there. We cannot load bulk amount of data using this option. We can have the limitation of 50 MB. Say your file is less than 50 MB or 50 MB in size, then we can very well utilize the Snowflake web UI to load the data into Snowflake. And then we can use the Snowsql, which in turn uses the put and copy into commands to load the data. In this video itself, we are going to look into put and copy into in a greater detail. Example is placed here. So you can see put command used to put the file in the local directory into the specific table 20 table here. So this is one of the Snowflake stages. So it is like the table 20.csv file is loaded into this Snowflake stage named table 20, and then we will use the copy into command command to load the table 20 from the stage table 20, which is of the file format of CSV, and we are providing skip header equal to 1. This is one such example. As we discussed earlier, we are going to see lot of examples in the subsequent places. And then we can utilize the snow pipe for micro batch processing, which we discussed earlier here. Say if you want to load the data in near real time, say I want to load the data once in a minute or once in 2 minutes or so, then you can very well utilize snow pipe for that purpose. And for the direct streaming of data, Snowflake is providing snow pipe streaming API. It is the API which is available via the Java SDK, so you can directly write the code to stream the data into the Snowflake table directly. So Kafka can be used. You can use the Kafka connector along with the Snowpipe streaming API to directly load the data. And finally, there is something called data pipeline within Snowflake, again a new feature which can be used for complex transformations. Say if you are having lots and lots of transformations which is going to happen in your data pipeline, you can very well use the data pipeline, which in turn uses native Snowflake tools. It uses the Snowpipe for data ingestion, and it will load the data into the staging tables. Then it will utilize the streams and tasks to process the CDC and everything, and finally it will load the data into the Snowflake table. Now we are going to discuss about various data loading options within Snowflake. We can call it as end-to-end options which are currently available. I just try to encapsulate everything in a form of a single diagram. So by understanding that specific diagram will give you a clear understanding on how you can load the data into Snowflake. So in the left side you can see the various options which we discussed earlier. First let us start with the bottom, direct data loading. As we already discussed, any user can directly upload the files which are less than 50 MB in size using the Snowsite web UI into the Snowflake table, which is as straight as it is. So this is the simplest option. Now moving on to the bulk data loading, Snowflake provides us with varieties of options to bulk load the data. So first we will start with the source data. So for representational point of view, I just added databases, applications, spreadsheets and anything. It can be of any sorts of data. So any sorts of data can be ingested into cloud or local based storage. Cloud based storage are very evident. We can either store it in AWS S3 or Azure Blob or GCP's GCS buckets. Once the data got loaded into the cloud or local based storage, then we will move the data into Snowflake via different options. First of all, we are just going to see the local data. Local data meaning the files which are available within your local desktop or within your local laptop computer. Then what you can do, you can utilize the put command to place the data into the Snowflake stages. So here you can see put command is used to place the data into the Snowflake's internal stage, Snowflake's table stage or Snowflake's user stage. In the stages video, we discussed to a greater extent on these stages. Once these data got loaded into the stages, then we can utilize copy into to load the data into the Snowflake table. There is a small icon which is placed in front of copy into. This is the virtual warehouse icon. So for any copy into to get processed, we need the compute in the form of the virtual warehouse. That is the reason why I put this diagram in front of all the copy into. So using virtual warehouses, copy into, place the data into table. Similarly, we can place the data from table stage and user stage as well using copy into. Now say I am having my data in the cloud storage, say like AWS S3, then very well we can create the external stage for the files which are available in cloud storage. There is no necessity to use the put command here, as the data is already in the form of the external stage. We can utilize the copy into to load the data into the Snowflake table. Finally, we are having the option to directly copy the data from the cloud storage into the Snowflake table using the copy into command without using the external stages as well. With this, we can do lots and lots of varieties of bulk data loading using these tools. Moving on to to the micro batch loading, which we discussed earlier, which is loading the data once in 60 seconds or once in a minute or once in 2 minutes. Snowflake provides that option via Snowpipe. So if you are having and streaming data in the form of Kafka, what we can do, we can use the Kafka connector and the put command to place that files into the internal stage, and then we can utilize the Snowpipe's copy to place the data into the Snowflake table. You can see there is no virtual warehouse diagram which is associated here. Why? Because the compute required for the copy will be coming in the form of the Snowpipe. So the Snowpipe copy is different from the copy into statement with respect to the compute usage. Now the other streaming sources can very well ingest the data into any of the cloud storages, and then we can utilize the cloud based messaging system, which is SQS or EventGrid from Azure or PubSub from GCP, to load the data into the external stages, and then we can utilize the Snowpipe copy to load the data into the Snowflake table. Using these methods, we can very well ingest the micro batch data into the Snowflake. Finally, moving on to the continuous data loading part. Here we are directly loading the data as it is when it is coming with the microsecond millisecond latency. So again, we can utilize Snowpipe's streaming API, which is the different programming SDK, where you can directly call that Snowpipe streaming from your programs, Java programs, to directly load the data into the Snowflake table. This is as quick as it is. There is no intermediate here. Directly the data will be loaded. So these are all the different methods by which we can load the data into the Snowflake. Please spend some time in understanding this specific diagram. This will be very, very beneficial for your data loading examples. Now we are going to discuss about put command. If you remember in the previous diagram, there is a clear mention of put for 3 categories. For loading the data into the Snowflake stages, we need the put command. So what are all the use cases for put command? Put command uploads the data from the local file system to one of the following Snowflake stages. As we already know, a named internal stage or specified tables internal stage or user internal stages. Put command does not support uploading the files from the external stages. Again, this is very evident from the previous diagram. Duplicates are ignored if you use the put command, meaning if you are trying to upload the same data into the table using the put command, the duplicates of the data will be ignored using put command. So what are all the examples? Here you can see the same one which we saw earlier. Here it will put this specific file mydata.csv into my underscore int underscore stage, which is the internal stage. So it upload mydata.csv to an internal stage named myint stage. See, here you can see the wildcard operations is also possible. So you can use the wildcard to upload multiple files into the table stages. This is one such option. Instead of loading orders underscore star 01. So whatever the files which are in this specific naming convention, whatever the place on which the star is mentioned, though all these data which satisfies this specific condition will be loaded. So this will load all the multiple files into the orders tiny underscore ext stage. So these are some examples of how we can put the data into the stages. Now we are going to discuss about one big chunk, which is the copy into. A clear understanding and deeper understanding of this topic is very important from the exam point of view and also from the data loading point of view. So we are going to spend some good amount of time in understanding this copy into command. So there are two options available. One is copy into table and other one is copy into location. Copy into location is all about data unloading. We are part of the data loading video. So copy into table is which is very required for the data loading. It loads the data from the staged files to the existing table. The files must be already staged in one of the following locations: named internal stage, a table stage, or a user stage. This is what which we saw using the put command. We can use the put command to put the data into any of these three stages. Files can be staged using the put command. And then name the external stage that references the external location, say it as AWS S3 or GCS or blob. And then the external location, again AWS S3 or GCS or blob. If you remember the previous diagram, everything is represented in a clear way. And then there are some options of transformations which are supported using the copy into command, meaning while using the copy into command, we can specify some transformations on the data which is going to be loaded into the Snowflake table. What are all the transformations? You can do column reordering, you can do column omission, you can do casting, you can truncate the text strings that exceed the target column length. So these four are very important for your understanding, and also from the exam point of view, these are all the transformations which are available while loading the data using the copy command. As we already discussed, the copy command needs an virtual warehouse to process or copy any of the data into the Snowflake tables. Here we are going to see a handful of examples, not some of the examples. We are going to see handful of examples for how we can utilize the copy into. First example is all about loading the data from the internal stages. As we all know, there are three types of stages available. First is the named internal stages. Here you are copying the data from the internal stage myInt stage into the table myTable. This is all about the table stage. Here you are copying the data from the table stage. The table stage name is same as the table name, so there is no need to give any of the name over here. This will copy the table stage data into the my table. And finally, this is all about the user stage. Now you are copying the data from the user stage named /_stage using the file format into the table named my table. So as simple as it is, you are having the opportunity to load the data, to copy it from any of the stages into the Snowflake tables. Moving on, loading the data from the named external stage. This is all about the data which is stored in the cloud-based storage, and we are just creating an external stage alone. Now you can see this is the external stage, my external stage, which is the external stage which is already created, which is under the S3 or any of the Azure Blob or GCS. We are going into the specific folder and we are taking the contacts1.csv and load that data into my CSV table. And now we can do some other operations as well, loading the files using the column matching. Here you can see the case insensitive statement here. So the whatever the files which are there which matches the columns, even though the case is not matched, it will load the data into that specific table. This is again an external stage. You can see this is stored in the form of the semi-structured data as sales.json. So the file format is defined as JSON, and it will load the columns which are even case insensitive as well. Loading the files directly from an external location, this is something which is very important, as we saw as the part of the diagram. So we can have the opportunity to directly load the data from the cloud storage to the Snowflake table. This is one such example. They already created a storage integration named myInt, which stores the AWS credentials which are needed for this operation. So from the S3 bucket, my bucket data files, it will take all the details and then using this file format, and it will upload that data into the table named my table. This is an example for GCS. Here also the same, again they created a storage integration named myInt. It is going to take the data from GCS bucket named my bucket _ data _ files, and it will put the data into the table named my table. Now we are trying to do the data loading using pattern matching. Here you can see these are all the wildcards. Pattern matching is all about loading multiple tables using one command. Here you are seeing whatever available within this specific folder using the type of csv.gc. All the files in this specific folder will be loaded or copied into the my table. Again another example. Here you can see sales.star.csv, meaning whatever files which are in this specific name, as we saw in the put example, the wildcard here. Say I am having the file name as sales.01.csv, sales.02.csv, sales.03.csv. All the files will be uploaded as the part of this. That is the reason why it is called as the pattern matching. Now we are just trying to understand some of the semi-structured data loading. We are going to cover semi-structured in a greater detail in the subsequent videos, but for the understanding, copy into also supports data loading in the semi-structured way as well. Here you can see create or replace file format. First we are just trying to create a file format for the JSON. Strip outer array equal to true, meaning the outer array will be cut off. Then we are trying to create a stage named my stage using the file format of JSON format which we already created. Then we are using the put to place that file from the local system into the specific stage. Here you are placing it into the my stage using auto compress equal to 2. Then we are creating the table named house sales, which is having the column src with the data type of variant. Again, for semi-structured, we are having multiple data types available. Variant is one such data type which will allow you to store the semi-structured data into the Snowflake table. So that is the reason why we are creating the house sales with the source field as variant. Then we can simply utilize the copy into command using that stage which we already loaded into the table house sales. Now we are going to discuss about copy options. As I told earlier, copy into itself is a kind of a very big chunk. So we are having lot of options which are available within copy into to do varieties of things. Copy options is one such on that complete list, which is very very important for you to know. Why? Because the copy options provides us with lot of beautiful information which can be used while loading the data into Snowflake. So please see this table. This table contains all these details. Copy option is the option which is provided, and what is the definition for that option, and what is the default value for that specific option. First thing is on error. On error is a string which specifies the error handling for the load operation. Meaning, if you are loading the data using the copy into statement, say what if an error happens, then based on the type of the error, you can do any specific action. Those actions are specified using this specific copy option. First thing is continue. What it will do, it will continue to load the file even if errors are found. As simple as it is. Skip file. It will skip the file when error is found. Say if you are loading multiple files into the system using copy, then whatever the file which is causing the error, it will be skipped. Skip file underscore num. This will skip the number of error rows found in the file equal to or exceeds the specific number. So if you can specify skip underscore file underscore 10, if it find 10 errors, beyond that it will not load the file. As simple as it is. Again, skip file num percentage. This is more or less similar to the number. Here based on the percentage of the error rows which is found in the file exceeds the specified percentage. Say if you are giving 10% or 5%, based on that, say if you are loading 100 rows using that specific copy into, if you specify 5% there, if you are getting 5 or more errors, it will get skipped. It's like it will, the specific thing will get skipped. Finally, abort statement, which is very evident, it will abort the entire load operation if any error is found in the data file. So these are all something which is very interesting to use based on your use cases. So what is the default value for bulk loading of using copy? Abort statement is the default value. For the Snowpipe, skip file is the default value. Moving on, size limit. number. So the number which is greater than 0 specifies the maximum size in bytes of data to be loaded for the given copy statement. When the threshold is exceeded, the copy operation discontinues loading files. As simple as it is. If you want to limit the size of data which is loaded as the part of the copy into, then we can very well utilize this size limit. Purge equal to true or false. Again an interesting parameter. Boolean meaning binary which is true or false, that specifies whether to remove the data files from the stage automatically after the data is loaded successfully into the Snowflake tables. So if you are loading the data using the Snowflake stages, it is good to remove the data from the stage once the data got loaded into the Snowflake tables. That is as the part of the best practices from Snowflake. So this command will help you to do that using the purge equal to true, but default value is false, meaning what? It will not remove the table files from the stages. Return failed only equal to true. Again a Boolean expression which specifies whether return only files that have failed to load in the statement result. As simple as it is. Match by column name. String that specifies whether to load semi-structured data into the columns in the target table that match corresponding columns represented in the data. To make it very clear, you need to understand these statements very clearly. So this is very helpful in loading the semi-structured data with the right columns in the target table. Include metadata is again a new feature which got added into copy options. A user defined mapping between target tables existing columns to its metadata columns. Default value for that is null. Enforce length equal to again binary true or false. This Boolean operation will specify to truncate the text strings that exceeds the target column length. If you define it as true, produces an error if loaded string exceeds the target column length. If it is false, strings are automatically truncated to the target column length. Default value is true. So by default, if you keep it as true and if you try to load the data in a bigger or a smaller sized data type, automatically it will throw an error. Truncate columns, true or false. Here again an ulta to the previous case which we discussed. It's a Boolean expression that specifies whether to truncate text strings that exceed the target column length. If you do true, it will smoothly truncate, automatically truncate the target column length. If you do it as false, it will produce as an error if loaded string exceeds the target column length. Default value here is false. So by default, Snowflake is not allowing you to load the data of different sizes there. So force equal to true or false. Again another good parameter. If you want to forcefully admit Snowflake to do any of the operations, then you need to do. Ideal example is duplicate loading. If you want to load the data duplicates into Snowflake, by default it will not do. If you want to do it forcefully, you can utilize this command, Boolean command that specifies load for all files regardless of whether they have been loaded previously and have not changed since they were loaded. Note that this option reloads file, potentially duplicating the data into the table. That is something which you need to know. Default value for the force is again false. Finally, load uncertain files. A simple thing to know, Snowflake maintains the load history metadata for 64 days. So whatever the files which you loaded beyond 64 days, those metadata will not be available, and those specific files are mentioned as uncertain files. So how to load those specific files using this command? It is again a Boolean expression that specifies to load files for which the load status is unknown. The copy command skips these files by default actually. So the load status, how it is manipulated, it is using the last modified days which is more than 64 days older. The initial set of data was loaded into table more than 64 days earlier. If a file were already loaded successfully into the table, this event occurred more than 64 days earlier. So default value is false, meaning it will not load uncertain files. But if you want to load those specific files, you can very well utilize the option of true. Now comes some of the examples. Here you can see reloading example using force equal to true, which we already discussed. See test1 and test2, which we already loaded into the load1 table, but we are forcefully asking Snowflake to load that again using copy into, utilizing the force equal to true. Again, if you see purge equal to true, this will purge my staging tables based on this command. So once the data from the stages will be loaded into my table, automatically those stages will be purged. Now we are going to discuss about copy into in the validation mode. So far we discussed copy into to a greater extent on data loading, how we can load the data using the copy into with varieties of copy options and everything. But you can utilize copy into as a part of the data quality checks as well. Instead of loading, it will check your data for the data quality checks and then it will return you the specific results. That is helpful via this validation mode. So what is a validation mode? It's a string or a construct that instructs a copy command to validate the data files instead of loading them into the specific table. Important thing to know, copy command tests the files for errors but does not load them. So if you specify copy into with validation mode, it is just for the data quality checks alone. It is not for your data loading problem. The command validates the data to be loaded and return the results based on the validation option which is specified. What are all the various validation options? There are 3 validation options which are available. First one is return n rows. For example, it is return 10 rows. Validates the specific number of rows if no errors are encountered. Otherwise, fails at the first error encountered in the rows. So if you want to validate, say like first 10 rows or first 20 rows, then you can utilize this option. Return errors will return all errors which are across the copy command. Say if you are trying to return all the errors, say like parsing errors or conversion errors which are across all the files specified in the copy statement, then you can utilize return errors. Return all errors is slightly different from return errors. It is all about a complete data load, meaning whatever the data which is previously loaded. So here you can see that return all errors of all the files specified in the copy statement, including files with errors that were partially loaded during earlier load, because the on error copy option was set to continue during the load. So this is important thing to know. The return all errors will return you all the errors for the previously partially loaded files as well. Coming to the examples, the first example is to see all errors here as we already saw. So copy into my table validation mode equal to return errors. This will return me all the errors which are possible across all the files which are specified in this specific copy into statement. And moving on to the next type, specifying the number of rows using the first option, return 2 rows. If you see here, return 2 rows, return me the table data, meaning there are no errors there. But if you see return 3 rows here, is returning me an error. Why? Because the table is not having enough number of rows to be returned. It is having only 2 rows alone. So by doing so, you can very well see how these things behaves with respect to the data quality. So finally, we are going to discuss about data loading best practices. So far we discussed about what data loading is. We saw an interesting picture representing complete end-to-end data loading, and then we discussed about copy into, options within the copy into, and how we can utilize the copy into in the validation mode and everything. Now slightly changing the topic, not completely changing the topic, we are just trying to see what are all the Snowflake recommendations for data loading. Snowflake provides some good set of recommendations for loading the data. First one is on the file sizing. So how my file size is going to look like? The number of load operations that run in parallel cannot exceed the number of data files to be loaded. Important point to note, to optimize the number of parallel operations for the load, aiming to produce the data files roughly 100 to 250 megabytes or larger in the size compressed. So Snowflake recommendation for file size is 100 to 250 MB. Aggregate small files to minimize the processing overhead for each file. Again, something to know, say if you are having large number of small files, it is not good, so you can aggregate or you can combine the smaller files into a bigger file of this size 100 to 250 MB. Split larger files into a greater number of small files to distribute the load among the compute resources in an active warehouse. The ulta is also correct, meaning if you are having a very big file, split that into smaller files. These two things are important. For the semi-structured data, there is a caveat. A variant is a column which can allow a semi-structured data to be loaded into it. So if you want to load a JSON data into Snowflake, then variant is the ideal data type. But variant is having a maximum size up of 16 MB for an uncompressed data. So 16 MB is the maximum file size for variant. So what is the recommendation from Snowflake? Use the strip outer array command. If you remember, as the part of the example, we did the strip outer array. So if you are exceeding the 16 MB limit, then utilize the strip outer array file command to remove the outer array structure. Snowflake extracts a maximum of 200 elements per partition per table for the semi-structured data. When it comes to the Snowpipe, again the same recommendation of 100 to 250 MB. A good balance between cost, that is the resources spent in the Snowpipe queue management, and the actual cost and performance is the better way to choose the file size for the Snowpipe. So what is their recommendation is 1 minute interval. Try to load the data into Snowpipe once per minute. So keeping the buffer interval and setting it for 60 seconds at the minimum value helps to avoid creating too many files and increasing latency. As you all know, Snowpipe is all about direct data loading or continuous data loading. So it is always better that instead of loading the data in the multiple phases within the shorter duration of time, we can use an 1 minute interval or 60-second interval, chunk it to that specific interval, and then load it into Snowpipe. Moving on to the load plan. So as simple as it is, there is only one recommendation from Snowflake, which is the dedicate separate warehouses for loading and querying operations to optimize the performance for each. As simple as it is, do not ever create a single warehouse for all your operations. Create multiple warehouses for all your operations. That is very easy for your management perspective and also for the auto suspension perspective. Let us take a simple example. If you are trying to load the data using the virtual warehouse, same copy into needs the virtual warehouse. See, data loading cannot happen for all the day. If you are aware my data loading is going to happen in this 2-hour duration alone, then simply you can create a virtual warehouse for that specific duration, utilize that warehouse for data loading and suspend it. For the queries, you can create another warehouses. By doing so, you can save lot of cost within Snowflake. That is the recommendation which they are giving. Moving on to staging data. Here, how we can stage the data. When staging regular data sets, partitioning the data into logical paths that include identifying details such as the geographical location or other source identifiers along with the date when the data was written. This is an same logic of partition. If you are from the data engineering, data warehousing background, you might be aware of partitioning. So similar way by which the clustering and everything works. So if you store the data in the micro partitions, meaning instead of storing everything in a single folder, you can create separate folders for separate things, say a separate folder for a specific day, so the data processing can be very well enhanced. So that is what they are trying to say using this. Organizing your data files by path let you copy any fraction of the partition data into Snowflake with a single command. As simple as it is, this allow you to execute concurrent copy statements that match a subset of files, which takes the advantage of parallel operations. There are two advantages which are mentioned here. If you want to fine grain or go to that specific location, then also partitioning is helpful. If you want to do the parallel data load, then also the partitioning is very helpful. Here is one such example. Here you can see within the country of United States, within the states of California, within that this is the specific Los Angeles state, and then 2016 is the year, and then if you can see this is the specific month, and then within that we will be creating the specific day, and then we are creating my data. This is how we can do that. And similarly it can be useful in doing the copy command as well. Here the same thing which is mentioned on the top will be used to load the data, as simple as it is. And then what about the loading data? What are all the recommendations from Snowflake? As we already discussed, the load metadata expires after 64 days. So if the last modified date for the staged data file is less than or equal to 64 days, the copy command can determine its load status for the given table and prevent reloading or any data duplication. I hope this statement is very evident, as we already saw about uncertain files. To load the files whose metadata has expired, already we know the load uncertain files in the copy option to true. This is one such thing. In the variant column, null values are stored as the string containing the word null, not the SQL null value. So what is the recommendation? It is a meaningless word. Say if you are storing the word as null, there is no meaning to it. If you store it in the SQL null value, then only there is a meaning to it. We can mine the data and we can generate some insights out of it, say like total number of null value, whatever. So how it can be done? You can utilize the strip null values to true, which is the option which is available for the semi-structured data. If external software exports the fields enclosed in the codes but insert the leading spaces before the opening quotation character for each field, Snowflake reads that leading space rather than opening quotation character as a beginning of the field. How I can overcome this problem? You can again utilize the trim space file format option to remove undesirable spaces during the data load. Ideal example here you can see I am using copy into from the stage. File format here is type is CSV, trim space equal to true, field optionally enclosed by 0x22. This will smoothly remove the leading spaces in your files. Finally, we are discussing about managing the regular data load. Say I am going to load the data in a regular way. What are all the options? The same one which we already discussed, partitioning the staging data files. As simple, same thing which we already discussed here. So I am not going to give more attention to it. So store the data in the properly partitioned way, as it is mentioned here: bucket name, application to, location, and then with the date kind of a scenario. Removing the loaded data files. So this is also again another important thing. So if you keep on adding data to your stage, it will unnecessarily increasing your cost. So when the data from the staged tables, staged files are loaded successfully, consider removing the staged files to ensure data is not inadvertently loaded again or duplicated, and also reduces the number of files that copy commands must scan. So for both the reasons, to avoid the duplicate data loading and also to unnecessary scan, copy command unnecessarily scans the extra files which is already there, we need to delete that. What are all the options? You might be already aware. We already saw this to a greater detail. Using the purge copy options, we can very well purge it, or else you can use the remove command to remove the files in the stage. With this, we come to end of this video. I hope this video has been informative for you. As usual, I am going to add all the Snowflake documentation links in the description of this video. Please do write lot of comments. That will be helpful for me to enhance the course contents. Thank you very much for watching this video.